All right, so this is a fraction of a whole. It wants us to use numbers and labeled sketches to solve the problems on this page to show your work. So Nathan participated in a 5K or 5-kilometer race. He walked 1/4 of the way, jogged 3/5 of the way, and ran 3/20 of the way. How many kilometers did Nathan walk? I normally like to use number lines on this for distance. All right, and we are doing 1/4. So if we have, here's 0 and here's 5, I know half is what, 2.5, and so that means a quarter is 1.25 or 1 1/4. So Nathan walked 1 1/4 kilometers. Now, I could also use numbers to figure that out. So if I have 1/4 of 5, that's going to give me 5/4, which, again, if I remove that 4/4 to make it one whole, it gives me 1/4. So those line up. How many meters did Nathan walk? This is the mistake I made. I was thinking there was 100 meters in a kilometer because I was thinking centimeters to meters. There are 1,000. So if we have 1.25 kilometers, and we are multiplying that by 1,000, that's going to say we are doing 1,250 meters. All right. How many kilometers did Nathan jog? All right, so now we are looking at this and thinking about this in the terms of fifths. Well, and what's nice about fifths is what? There's 5 kilometers, so 3/5 is just going to be here, right? So if we split this whole thing into fifths, 1, 2, 3, 4, 5. There's our 5 fifths as a whole, and then 3 of those fifths is 3 kilometers. Let's see if that works out with our numbers as well. 3/5 times 5 kilometers equals, you do 1/5 of 5 times 3, which equals 1 times 3, which equals 3. So yeah, so Nathan jogged 3 kilometers. All right, how many meters did he run? Again, so 1,000 meters equals 1 kilometer. So that means he jogged, so 3 times 1,000 equals 3,000 meters. All right, how far in kilometers did Nathan run? So now we got 20ths. Okay. Now this one gets a little complicated to think about because here's 0, here's 5. How do we get it to 20ths? So we have to think about this. All right, so if we have 5 kilometers, 1, 2, 3, 4, 5. What do I need to split each one into to turn this whole thing of a 5-kilometer race into 20ths? What's the relationship between 5 and 20? That's right, 5 times 4 is 20. So that means if I split all of this into fourths, I now have 20 20ths in my whole race. So 20 20ths, my whole race is 5 kilometers. So that's my whole race. Now, Nathan only ran 1, 2, 3 of the 20ths. So what is that of the whole race? Well, he went 1, 2, 3/4 of 1 kilometer. So Nathan ran 3/4 of a kilometer. So let's look at that in terms of numbers. So if we have 3/20 times 5, we can look at this as 3/20 plus 3/20 plus 3/20, so 5 times. So this turns into 3 times 5 over 20, which gives us 15/20. Well, wait a second, I thought it was 3/4. Well, we can divide each one of these by 5 to simplify, and that gives us the 3/4. Okay, so 3/4. This is cool though. I like this. All right, how many meters did Nathan run? Well, again, we have 0 and 75, because 3/4 is the same as 0.75, times 1,000, and that's going to give us 750 meters. Because again, it's less than 1,000, right? Because this is less than one hole, and so that makes sense there. Deja's bedroom is 9 square meters. She just got a new rug that covers 3/5 of her bedroom floor. How big is Deja's new rug? Well, if her room is 9, we have 3/5 of 9 meters. I mean, if this was 10, that'd be cool. I could do the over, couldn't I? So I could do 3/5 of 10 minus 3/5 of 1. That will give me 3/5 of 9. So 1/5 of 10 is 2, times 3 is 6, minus 3/5, which gives me 5 2/5 square meters. So Deja's rug covers 5 2/5 square meters. Page 2. Write a story problem for 2/3 of 4, then solve your own story problem. Well, your problem, we've had a lot of problems here where you could use distance, you could do like 2/3 of 4 kilometers. You have 2/3 of 4 square meters. So something of that nature would have been what I would have done. And then we're going to solve that problem. So 2/3 of 4 equals, well, I could chunk this to 2/3 times 3 plus 2/3 times 1, which gives me, again, 1/3 of 3 is 1, so 2/3 is 2, plus 2/3, which equals 2 2/3. All right, solve the combinations, show your work for each, use one or more of the strategies on the chart that we made on Wednesday morning. I don't know if when you'll be doing this. 3 times 3/4. I mean, I think I would probably just turn that into 3 times 3 over 4, which equals 9/4. Here, 6 times 2/5. Just anything there. I guess I could go 6 times 2/5 equals 5 times 2/5 plus 1 times 2/5. 1/5 of 5 is 1, so 2/5 is 2 plus 2/5. 2 2/5. 8 times 2/3. I guess I could put that to 6. I mean, I've grown to love the chunking, just because it seems to be an efficient way to think about things, to kind of practice doing that in your head. And then it makes going from going from an improper fraction to an improper fraction to a mixed number can be kind of tricky. And this, for me, this simplifies it. So I have 6 times 2/3 plus 2 times 2/3 thirds, which is going to give us 1/3 of 6 is 2, so 4 plus 4 thirds. And again, we can turn that into 4 plus 1 plus 1/3. Because again, I took that 3/3 out to get 1 whole, and I have 1/3 left, which is going to give me 5 1/3. All right, fill in the blanks, and then we're going to find and describe at least one pattern. Okay, so 1/4 of something is 9. Well, 1/4, how do I figure that out? 4 times 9 is 36, so that means 1/3. 2/4 of something is 9. 2/4 is 1/2, so that would be 18. Oh, okay, that went down by half there. 3/4 of something is 9. My number is going to be less, isn't it? Because this factor is growing. That's a pattern I could talk about. Oh wait, this is 9, right? Because this is 1. 1 times something is 9. 3/4 of something. Well, if I know, does that 1/4 help me? I don't think it does. What's the best way to figure this out? I think it's 12. Because I kind of was thinking of this backwards. So I knew that 1/4 is 36. And then I divided 36 by 3 to get to 12. So let me think if that worked there. 1/4 of 12 is 3 times 3 is 9. So again, I went 9 times 4 is 36 divided by 3 is 12. Let me write, so I did 9 times 4 and then divided by 3. And thinking that way got me this number, and that proves correct. Cool. All right, find and describe at least one pattern. Well, what I notice is to keep the product the same, one factor increased while the second factor decreased. Something else to note, look, fraction, right? Proper fraction, whole number. Product is less, product is less, product is less, product is the same. And if this went to like 5/4 or something, then this would be more. So anytime we're dealing with proper fractions less than 1, greater than 0, our answer is always going to be less than the other factor. Always, no matter what is going on. All right, fill in the blanks. 1/5 of something is 15. Well, again, we can think of that as 5 times 15, which, 5 times 10 is 50. 5 times 5 is 25. That would be 75. Now, this has doubled. So if this is doubled, then this needs to double, so that's going to be 150. Okay, doubled, 300. And then this doubles again, so this needs to be 600. All right, so to double the product while keeping one factor the same requires you to double the other factor. Okay. Alrighty. Challenge time. 5, 4. Ooh, 5. So this is over a whole. So this number is going to be bigger. So what was that thing I used over here? What about 10 times 4 divided by 5? So 10 times 4 is 40. Divided by 5 is 8. Does that make sense? 40/4, that's 10. All right, cool. This is a nice little thing we figured out here. 9 times 4 divided by 8. Oops. So 9 times 4 is 36. Oh, wait, that's just 2. 2 times something is 9. Well, here, 36 divided by 8 Yeah, that's not, no, so this is just 2 times something is 9. Or 9 divided by 2, so that'd be what, 4.5, 4.5. Because I should have just looked at that. See, this is what happens. So you find something to do and then you just do it instead of thinking. I should have stayed and thought. 3/5 of something is 30. So again, this number is going to be greater than 30. We could do this 30 times 5 is 150 divided by 3 is 50. 1/5 of 50 is 10. 3/5 is 30. 4/5 of something is 60. Is there any relationship there? No. I mean, this doubles, but the factor has changed. So again, 60 times 5 is 300 divided by 4. 300 divided by 4? Oh, that'd be like 1/4 300, so 175. So what did I do there? Let me slow down my thinking for you there. So again, I did 60 times 5, and then I divided that by 4, which took me to 300 divided by 4. And I know one way to divide by 4 is you divide this number twice by 2. So I did 300 divided by 2. And then whatever that was going to be, I was going to divide that by 2. Oops. Which is the same thing as saying 150 divided by 2, which gave me 75. Oops. There. All right. Bye. Don't forget to fill out the form. Let me know how things went.